Hello guys, so this is just a short video highlighting, or giving you some tips about homework 4. Okay, so we have solved a similar problem when we talked about diffusion current in BN junctions. Okay, and here is a simpler example. That's really simpler than that was the ones that we took. The ones that we took, it was non-linear and stuff. This is linear one. Okay. So here again you have a sample, this sample like this. Let's draw it. A sample of silicon. It has a length, some length, and we are interested in the region from 0 to L. So if this is, for example, the x-axis, I mean its length is across x-axis, we are interested from the 0 to L. And L here is 10 to the power minus 4 centimeters. Or 100 microns, So the density is changing according of the holes. This is for the holes. B, of course, the density of holes. N is the density of electrons. B is changing based on such. I gave you the graph, the relation itself. And it's a linear relation, as you see. So basically, this one can be written as AX plus B. And I'm pretty sure, and I hope I'm right, that you can get A and B. You can construct, I mean, this relation. Okay, based on that figure here. Just review how to determine the slope of a linear curve, how to determine B, and you will just get it. B should be the intersection with y-axis. Okay, so basically these are but you need to get AX plus B first correct, so you can continue correctly the rest of the questions. This is the basic one. Okay, so B of X is changing from 0 to L based on that. Then after L it's just constant. As you see here, it's constant here. From 0 to L it's linear, and after L for X greater than L it's just constant. Okay guys, this is the whole concentration or the whole density. How many holes you have per volume. The volume can be micrometer cubed, centimeter cubed, meter cubed. Okay, so the units of this, just if you review the lecture, you will find, of course, this information. It is holes per, for example, centimeter cubed. In that example here, I am measuring everything in centimeter cubed. Some books does not consider in writing these holes and write it as in that way, per centimeter cubed, without mentioning holes or electrons, because they are just numbers, they are not a unit like centimeter. It's not a metric. Okay, so they just write it without the first part, just write per or centimeter minus cube. Okay, so all these are just equivalent. Okay, good. So and you have, as you see, everything is in multiple choice, so it will be easier for you. And here is why I'm saying this kind of units. So when you find centimeter minus cubed, I mean here holes per centimeter cubed. This is just centimeter minus cubed, because some books do not write holes or electrons. Okay, good. Now you know that NB equal to NI squared. Okay, so basically N can be equal to NI squared divided by B. We learned, or we took many examples in which B is a constant and N as a constant, and we get, for example, if B is equal to 10 to the power 16, then N is equal to NI squared over 10 to the power 16. If 10, if n is 10 to the power of 10, this will be 10 to the power of 4. So in our previous examples, b or n was constant, and we can get the other based on the known one. Okay, but here no, here b of x, it's a b of x, it's not constant, it's changing with x, right? So you need here to remove this b and put ax plus b, and this whole equation here can be rewritten as 1 over cx plus d, and I will leave this to you because this is basically the question, how to get c, how to get d. Okay, so you can determine n of x now, not just, it's not a constant. Okay, then here I'm asking about the gb of x in two questions, so you need to calculate gb of x. You know, I gave you the equation in the lecture, so go there, determine it. Okay, it should be a function. I mean, a function can be constant, can be increasing with x, can be decreasing with x. If it's a two-dimensional function, it may be also a function of y, not just x and y. But I will give you a hint here. Here, b of x is just changing with x. Okay, just a change. It's a function only in x. That means that b is uniform across y. So, okay, you have some incorrect, choices here. I will not go beyond that. I think you get my ideas. Okay, that's good. Now, yeah, the last question. Okay, which is sketching, b of x, n of x, versus x. So I want you, based on the graph that I gave you, which is b of x, I want to draw n of x or plot or sketch, not to scale. A sketch means just put the important points. Okay, be careful with higher or lower. For example, here b is equal to 10 to the power of 17 at 0 here. So if n is less than 10 to the power of 16, don't make n of x or n of 0 here. I mean higher than 10 to the power of 17, or make it lower, right? So that's basically sketching. We don't care much about the scale, but we care about the relative relations, like who is bigger than who is smaller than, this kind of relations. And remember to draw it from 0 to L. I want you to put on your sketch n of 0. You should locate it, n of L. And then for n greater than, for x greater than L, I want you also to show me how n of x will change. Is it constant? Is it increasing with x? Is it decreasing with x? You should figure this out. And here, b of x, as I said before at the beginning, b of x is constant for x greater than. This is just I know from the for the graph here. Look at the straight line, horizontal straight line. So try to figure out how n of x will behave as x is greater than L. Is it constant? Is it increasing with x? Is it decreasing with x? Then from x greater than 0 and less than L, I mean in that region here, you should draw n of x. N of x, as I said here, if we go up, can be written as 1 divided by cx plus. This is a non-linear relation. Okay, so n should be a curve, So you should figure out if this curve is increasing with x or decreasing with x. If it's increasing with x, draw it like this or like this. I will accept both. You can. So again, if it's increasing with x, you can draw it that way or that way. This is right. This is also right. Although one of them is only right, but just to make it easy for you. I just want you to have the sense of drawing or sketching linear functions. If you are talking to your manager and you know n of x, your manager will not be that, harsh with you if you just sketch it as like this or like, but draw it non-linear. No, don't draw it like this. This will not be acceptable if you draw it as a straight line, as it's linear. Okay. If it was decreasing with x, so draw it like this or like this. I will accept both. Okay. Of course, if you are really, nerd, you should draw it in MATLAB. You can plot it in MATLAB. Okay, just give MATLAB the equation of x. I mean this equation here. Give it c, give it d, get some range for x. Then you can plot it in MATLAB. And MATLAB will give you, if it's like this or like this or like this or like this. It will be nonlinear. Okay. So this is basically, the most important information or tips about this homework. Okay. Again, I'm stressing that you should draw n of x on the same graph. I mean, you download this one. Download this figure. It should be in the files of the course. Download it. And it's, as you see here, it's scaled. You see these small squares, small cells here. So you can make a good sketch. I don't want you to do something bad. If I didn't recognize what you are drawing, I will just give you 0. Sketching is a very good skill, and it's not just very good, it's a necessary skill for a good engineer. Okay, so I want to see something clear, something readable, something, informative. Okay. And again, since it's multiple choice, I gave you one attempt to submit. So be careful before you submit. If you are sure about your answers, click submit. Okay, guys, I hope this is helpful for you. Thank you very much and have a great day. See you next week. Bye-bye.